Welcome everyone. Another virtual BioMedIA seminar. We are very fortunate that Lena Maier-Hein has accepted our invitation to speak to us today. I know everyone is really struggling to find time, so this is really great that you do this. So some background about Lena. She's a professor at the German Cancer Research Center, where she's leading a quite large group working on all kinds of problems. But I guess generally it's fair to say that you're focusing a little bit more on the Chi side of the MIC-Chi world, although I guess you do have people working on core MIC topics as well. So Lena studied and did also a PhD at the Karlsruhe Institute of Technology. She did then a postdoc at the German Cancer Research Center, and she's also not unknown to Imperial. So she spent some time not too far from our building at the Hamlin Center for robotic surgery. Then she went back to Germany, started as a junior group leader at the German Cancer Research Center, and did her habilitation over there, and is now a full professor. She's also a fellow of the MIC-Chi Society, so she's around at MIC-Chi for many, many years, probably as long as I can think. That's where we also, I guess, met or our paths crossed. So I know Lena for quite a while now. She's also a fellow of the European Laboratory for Learning and Intelligent Systems, the ALICE initiative that some of you might have seen, and they are doing a fantastic job in bringing people across Europe together and exchanging research, and they have seminars, online seminars with many talks available. She has received many awards. I'm not listing all of them, but yeah, one thing that I'm really excited about is that Lena, I think, did really a community service over the last couple of years by looking at some of the stuff we're doing, for instance, in the context of challenges. And some of her work has really led to a massive improvement in the way we these days run computational challenges at MIC-Chi, for instance. And I think this is part of the things she will talk today about. So really looking forward to this. The stage is yours, Lena. Thanks.
Yeah, thanks for this introduction. I'm excited to be here. I would actually prefer a physical meeting. Ben already mentioned my links to Imperial. I actually studied also 1 year at Imperial and then did my postdoc at the Hamlin Center. So yeah, it would be great to come back, but not the ideal time. But yeah, so this is virtual, so I cannot see you all, but please don't hesitate to ask questions in between. That makes me feel more integrated, I guess. Yeah, so we already talked about rats a few minutes back. So at the beginning of last century, there was actually a rat plague in Hanoi. And an initiative was set up to get rid of the rats. And basically what was done, they offered a monetary award for rat tails in the hope that this would basically lead to the rats being killed and then eliminate that plague. In practice, what happened, people cut off the tails of the rats and then let them alive so they could reproduce, and basically the opposite of the hope happened. More rats appeared. And this is basically an example of a proxy or a metric failing to achieve the goal that is actually desired. So today I would like to talk about how this actually relates to the topic of this talk, challenges. But let me first give you some background. So like Ben said, I'm from the German Cancer Research Center. It's the largest national biomedical research center. For a very long while, I was quite exotic over there, to the point that really our research, this also holds true for Klaus, was not very much acknowledged because we didn't publish in Cell and Nature, and we were just the computer scientists. This has changed with the hype of AI. So it's fun to see that all of a sudden, it seems like the perceived importance of this whole topic has risen. Yeah, and now I'm happy to be a full professor. So this is Heidelberg. I think it's actually a quite cute little town. Not as many opportunities as in London, but still a nice place to live in. This is the famous old bridge. We use it for our so-called bridge parties normally. That's really cool. And unfortunately, we had to cancel the bridge party due to Corona this year. But hopefully we'll resume later. Yeah, I told you before I went to Hamlin as a postdoc, and I basically always saw Guangzhong Yang showing his pictures with a queen, so I thought I should bring these pictures here. So if you come to Heidelberg, you would not be the first celebrity. I like to show this picture because I met Angela Merkel in, I think it was 2014, and since then I'm actually a fan of her. And I also think that she's ending the crisis very well, but that's that on the side. So my core topic is actually surgical data science. There was a paper last year that rose a lot of attention actually, which showed death within 30 days after surgery to be the third leading cause of death worldwide. I found this quite surprising myself actually. So my group is essentially working on data-driven methods to address this. So how did the challenges come into play? The real guilty person basically is Nasir Nawab. I'm sure you know him from his research at least. So he told me in 2014, Lena, I would like to make you satellite event organizer for MICAI 2015 in Munich. And please make sure there's a Chi challenge because there's only been MIG challenges around. So with Jan Stoyanov and Steffi Speidel, I ended up organizing basically a challenge myself or ourselves. And this was when I realized that it's not as easy as it sounds. And I realized that we also made some quite ad hoc and not so thought through decisions on, you know, how to compute the ranking or which metric to use. And that then made me think about this topic more thoroughly. And I remember telling Matthias, who's still in the team, I said to him, well, could you please take a quick look into this issue? Well, this quick look basically took many years and a lot of effort, but in the end, I think it was worth it. So I think you would agree that challenges are really important for the field, and especially a lot of attention is given to the winner of challenges. So people re-implement the work, the winner gets a lot of prize money, etc., etc. So the core question that we asked ourselves, at least the initial question was, is the winner really the best? And I'm presenting this work basically on behalf of a whole consortium. So a lot of these institutes basically gave us data for our studies, which was courageous because what we produced was actually a problem paper. So I really thank them for this. Particularly thankful I'm for those that drove the paper, some people from my team, but also the Division of Biostatistics at the DKFZ, and also the members of the Bias Initiative. So many thanks to you all that I can now present this work on your behalf. So some statistics initially. We had more or less steadily increasing number of challenges per year. I always had thought that 27 was the first year of challenges, but this was only the first year of MICAI challenges. So it turned out that actually the text retrieval community had already organized the challenge in 2004. When we analyzed where the challenges took place, we saw that about 50% of them were organized in the scope of MICAI. And my personal perception was that this changed recently, but according to an update of our analysis, this has actually been stable despite, for example, initiatives like DREAM or Kaggle. So if you look at the task categories, most of the challenges are actually about segmentation, followed by classification. Mostly MRI is used as modality, but also other modalities, both from MIG and Chi, basically. The more interesting part is maybe this. So we looked at the number of training and test images, and you all know the machine learning data sets with the hundreds of thousands or millions of images. And yeah, it's, I guess, a little bit sad that we are dealing with more or less hundreds. We also updated these numbers, not as comprehensively as in this paper, but we did a little poll to the MICA challenge organizers, and according to this poll, which may be representative, the numbers are still rising. So last year, we were already at least in the order of magnitude of thousands. Yeah, so of course the raw data itself is not what we're normally mainly interested, but a lot is about labels. And by the way, I just read an hour ago a paper that worked on the ImageNet challenges, and they produced labeling instructions 400 pages long. I found this quite impressive. And I think it underlines really the need to think very thoroughly about labels. So let me give you an example from the field of Chi. Here we are interested in basically tracking an instrument. Specifically, this is phrased as a segmentation problem in this case. And you may think intuitively, well, this is an easy problem, right? You just have to detect the artificial instrument in this image. That's easy from an labeling instructions point of view. But if you look into the details, then you see it can be quite tricky. So first point, what do you do with crossing instruments? Well, in this case, we decided to basically label the instrument in the foreground. But this can also be tricky, because then what do you do in the case of transparent objects, like in this case, a trocar? Do you then still not label the instrument in the back? Or we had these text overlays. So in the text overlays, we said, okay, here, let's basically exclude them from the labeling. But then we realized there's also other text overlays where you have actually the isolated digits. And then it would be really cumbersome, to annotate around them. So point being, even if it appears straightforward at first sight, the labeling instructions may not be as straightforward as you think. Of course, this also has to do with conventions. So this is not my field, but here, do you see my mouse?
Yep.
Yes, we can see.
Okay, great. Okay, so here it's mainly about the vena cava. So do you annotate it? From where do you annotate it? So different experts may disagree, and that's of course too important to consider in the instructions. Then of course there's the subject of inter-rater variability. I really like this paper from Leo Joskovic from Israel. So he actually paid he paid a number of radiologists to annotate a number of structures, and it turned out that the volume change when you look from observer to observer is really huge. And of course, something like this has to be considered when we talk about challenges, right? So basically, there's not the one ground truth that we can determine. So how do we deal with this inter-rater variability? Yeah, metrics. So finally, I come back to my rats. The dissimilarity coefficient is probably known to most of you. It's actually the most used metric in the field of biomedical image analysis competitions. It was used in more than 400 competitions. By the way, maybe I'm confusing you, because before I've only shown you a couple of hundreds of challenges. So I have to mention that we differentiate between challenges and tasks. So tasks are basically sub-competitions within a challenge. So for example, one team of organizers could organize a specific challenge, and they could have the sub-competitions, tasks of segmenting the liver, of segmenting the kidney, etc. So basically, a task is something for which a separate leaderboard is computed. So DSC, most frequently used metric, quite simple to understand. So you basically want to compare contours, and if you don't have an overlap at all, the dice would be 0. If you have a perfect overlap, the dice is 1, and everything else is basically in between. So sometimes the DSC is also used when, from my point, people really want to work on detection. And this is just one example of the pitfalls you can run into when using a specific metric. So here, I think the DSC as a contour matching metric makes a lot of sense in general. But now, if you look at the practical aspects, which are, for example, about resolution, then you may run into problems, because here, if you compare these two outputs of two competing algorithms, they actually only differ in a single pixel. And I don't know who of you has worked with a DSC, but basically a difference of more than 0.1 is huge. And now, if, for example, you are in a challenge situation and you have sometimes huge, sometimes small structures, then this small structure will really have a huge impact on the aggregated value potentially. So this is, just an example of the things that really need to be considered when choosing a specific metric. So coming back to the red, here I think it was clear that the metric, the proxy, didn't really match the goal. And I want to show you an example of a recent challenge. So basically, if you look at the formula of the DSC, a problem occurs when basically neither the reference contour nor the algorithm output anything. Basically, the area would be 0, or the volume. So in this case, you need to decide what to do with the data. And there's a popular challenge which basically just said, okay, in this case, we will set the DSC to 1. So then I talked to a participant of that challenge who I think was ranked, privacy. So he was ranked very high. And he said, okay, he pragmatically said that a DSC of 1 is so valuable as a score that if he only identifies a few pixels, then he'd rather set them all to 0 to basically have the potential gain of having a DSC to 1. And from a clinical point of view, that basically means that he may have more false negatives, right? So the metric really encourages, if people start to, basically overfit to the metric, would encourage more false negatives. Yeah, so let's assume you have chosen a metric carefully, considering all the problems that can occur, then still, or even multiple metrics, then of course you have to think about the ranking. Some background measure to understand how we deal with rankings, how we compare rankings. This is Kendall's tau correlation coefficient. So it basically gives you a value between -1 and 1 to compare two rankings. So if you have the inverse ranking, you get -1. If you have a perfect ranking, you get 1. To give you some intuition of this measure, here we changed first and last place. We got a tau of -0.2. In this example, number 3, we changed place 1 and 2, and we got a tau of 0.9. So just to give you an intuition, basically. So then what we did is we asked challenge organizers for their raw data of the challenges. And we ended up with about 50 competitions, each of which is now represented by 1 dot here. And then we did several experiments. This is just one of many. You can basically read all the details in the paper, but just to give you one anecdotal example, basically. So here we took, I think, the DSC as the most frequently used metric. We aggregated metric values with a mean, and we compared the ranking to a ranking that we would achieve with a median. And you see in this plot basically the spread of the tau. And if we pick this red representative example, you see that basically the aggregation method has quite a big potential influence on the ranking. In this case, the best ranked algorithm became 5th. Now, of course, mean and median are something completely different, but I think that the choice of whether you use the mean or the median from basically talking with challenge organizers can be quite random. And the point here is really to think this through properly. Another example would be different observers. I already pointed at that paper from Leo. We didn't have so much data to play with because most challenges only used one observer, but this is an example of a challenge that had 2 observers. And here, if we compute the ranking from one observer and compare it to the ranking from a second observer, you see that really everything is totally mixed up. And I think you would agree that this is actually quite disturbing to note.
Lena, can I ask a question?
Yes, of course.
So on this, when you say observer, does it mean that, let's say, in a segmentation task, you swap the ground truth that you compare with, or yes. what was the challenge here?
Exactly. So basically here, I think it was 2 radiologists, both annotated the same structures, and one time we used the annotations of one observer, and another time we used the annotations of the second observer. So this was admittedly quite anecdotal because, like I said, we didn't have a lot of data, but I think the paper by Leo is really cool in terms of showing the huge differences. And yeah, I think from what I've seen, it can have a pretty big effect on the ranking.
Do you remember if for this challenge, what was one of the observers the one who annotated the training data that people used, or was this?
Yeah, it's a good point. I think that that in this case they had some consensus ranking.
Okay.
But I can look it up. I don't remember exactly. It's 3 years ago. So, but I can look it up.
Thank you.
Yeah. So again, I think this part was a bit anecdotal from our side, as I said, because of the lack of data. But at least for the iterative variability, I think this is a very nice work by Leo. Yeah, so I only hinted at it with some examples, but our analysis was actually quite thorough. And if you're interested, just have a look at the paper. Cheating. Yeah. So maybe you would say that people won't cheat. At least that's also what one of our reviewers said. So I remember when Annika basically submitted her first paper to Maier-Hein, and we knew our paper was quite political because it was about cheating and the potential consequences. So we were quite excited about the reviews. And the reviews, I've never seen such reviews before, because I mean, I have been author and reviewer and area chair and program chair at Maier-Hein, but I have never seen such a review, which was basically 2 strong accepts, which is already rare, but in addition to a strong reject. So it could not be more radical. And that one reviewer basically said to us we should avoid suggesting that the community largely cheats. So if you don't think they cheat, I mean, I know it's not so easy to show, but from what I've seen, there's a lot of evidence that there's cheating involved. To give you one example, This is from a challenge from last year. And a specific participant basically submitted test case results. And I find it quite disturbing that the numbers agree basically to the last digit. Basically, from a statistical point of view, that only happens, the chance of two numbers being the same is 0. So there must be something systematic behind it. And then on the poorly performing cases, there was all of a sudden an improvement. So I don't know what happened, but to me, this doesn't look like that the method was generically improved. But to me, this very, very much looks like the knowledge from the test set was actually taken to tune the algorithm, which obviously shouldn't happen. And this leads me again to the discussion. I always fight about this with George Cardozo, that I don't understand why you need multiple test case submissions, but that's a different story. So essentially, our hypothesis is that generally speaking, people will be fair, but there will always be people that try to exploit the rules. I mean, for example, we've seen people, you know, when you were only allowed to submit one submission for the test phase, we saw new accounts that had results that correlated so highly with other accounts that it was clear that it was the same team. That obviously is also cheating. So I think it's a safe guess to say that it may occur. So let's look at some potential ways of cheating. So in our analysis, we found, if I remember correctly, that about 17% of the challenges that we organized at that time ignored missing values when aggregating metric values. So to clarify, what most people do is they compute a metric value for each test case, and then they have some aggregation scheme. So if there's no value, no submission, then what can they do? And one thing they can do is just ignore the value. So this, of course, is dangerous because if you look at these two tables, they only differ in the two values in which basically there's an NA in the second case. So if you want to exploit this strategy, you can basically selectively not submit results on difficult cases, right? So we did a little experiment based on 50 real-world challenges, and what we found was that basically 1/4 of the originally 400 non-winning algorithms could have been made the winner by selective test case submission. And in roughly 10% of the tasks, every single participating algorithm could have been ranked first. And this was not achieved by only leaving one test case. I mean, I don't remember the details, but it was sufficient to leave out you know, some of the hardest cases. Second example, from my point of view, also interesting. So also the organizers can cheat. And I was actually quite surprised how little detail challenge organizers release on the website before organizing a challenge. So often the metric is mentioned, but most of the time, and I'm referring to the time when we did this study, this was 2018. So many times they did not provide information on the ranking scheme. So essentially there's a lot of room for playing around with the data if you are basically a malicious challenge organizer. So say you play around with the data, then maybe your main competitor ranks first, you don't want that competitor to win, then why not you know, change the ranking a little bit and make sure somebody else wins. And this is actually quite well possible according to our analysis. So I will just present this to you in a more anecdotal fashion. Here, this is a challenge that has been run for many years, very popular, many citations. And what we do is we change around some of the main parameters. So we play with the 3 most frequently used segmentation metrics. We change the way whether we use the mean or the median, and we change the aggregation method. So basically what you can do, most people basically compute the metric values per case, and then they compute the mean or the median over it. But you can also look at each case individually and compute a ranking per case, and then you can aggregate. This last method is not so known, but it has, for example, the great advantage that you can easily handle missing values, because then you can just put the algorithm last. So we played around with these details basically, and this was the result. So as you see, the rankings is not really stable, and you have quite some flexibility to choosing the winner if you want, basically. Yeah, so next step, say you have taken care of the metric and the way you compute the ranking, then at some points you want to report the results. And I think I'm not a standards person. Actually, standards, I would go so far to say standards sometimes annoy me, because I just want to do the exciting stuff. I don't want to look at all the rules all the time. But really, I think when it comes down to proper science, then you have to be thorough, so your research actually means something. And when you report about a challenge, I think there's parameters that are really obvious, like how many training test cases are used, or which metrics do you use. But there's also parameters that are not at all very obvious. One would be what instructions were given to the annotators, or very importantly, can challenge participants complement the training data with their own data? Or, I mean, can they pre-train on a different data set? I mean, this all, as we all know, influences the performance of a method so much, so it should be made transparent what can or cannot be done, basically. So we looked at more than 500 competitions, and we defined around 50 parameters that we think should be reported. And we found that only about 2/3 of these parameters were actually reported by the challenges. So just one more or less random example would be that what I just said, that 85% of the challenges did not give instructions on the usage of the training data, for example. So again, the details are in the paper, but what we showed was that common practice related to reporting is really poor. So you cannot reproduce the results, you cannot really interpret them. And also, I didn't discuss this here, but it's in the paper, the challenge design is actually very heterogeneous. There's no standards, and the research community, according to a poll that we did, really wants these standards. Okay, so I'm not at the end of my presentation, but I'm at the end of the part in which we just criticize all the things that are going on. So I don't really like being so destructive about everything. But I think given the impact, the potential impact of challenges and the importance, we really need to basically do them right. And now I can talk a little bit more about the constructive part. So we have given basically some thought into how to improve challenges. We are definitely just at the very beginning of this, but I can share some results. And this was basically a contribution of the bias initiative that I mentioned before. So you may know that if you publish a clinical trial, then a randomized trial, then you have to basically submit a checklist along with it. That's called this consort statement. And we thought that given the importance of challenges for benchmarking AI algorithms, basically, we should have something similar for our community. So in 2018, we started basically taking the parameters that we identified and forcing people that wanted to organize a MICAI challenge to report these parameters. And we got a very mixed feedback. So people were, of course, annoyed. I mean, they were used to just, handing in an abstract that could be done quite easily, and all of a sudden they had to justify their split of training and test set, and had to really explicitly say what the challenge goal is and how the metric matches that goal. So mixed feedback by the community. But in the meantime, the system has been adapted from, for example, ISB and Middle. And personally, I think it may be a pain in the ass, but I think it's still an important step. So we extended this a little bit to also facilitate the actual reporting in papers. So what we developed is something like a checklist that both authors and reviewers can go through to see whether they reported the important information about the challenge. And yeah, of course, it's always annoying to have to follow guidelines, but I think it's essentially for the good. So we were quite happy to see when we invented this that the number of parameters that were reported with the submission system, which gave some freedom of not reporting some of the parameters. So we had all the information in the system. That was great. And then we said, okay, let's see what the organizers actually did. So did they report what we have in our system on their websites? So it's actually transparent to people that want to participate in the challenge. And this was actually not the case. So that was actually a little bit sad, because they had thought about all of this and basically not put it on a website. And even worse, we had them sign a document that if they make changes to the challenge design, that they would report it. So we have these signed documents, and basically nobody reported any changes, although there were quite important changes made. So this was a low light, for sure. So we thought, okay, let's take this to the next level. If you want to have a high impact publication on a clinical trial, then you first register your trial, and then you perform the trial. So let's go away from just that direct quality control, which we only have during review, and put in a second, we call that indirect quality control step. So once the challenge is accepted, the challenge design document is basically extracted from our submission system and put online. So now at least if some organizer violates the rules, then the information that was initially provided is out there, and he or she or they would need to justify themselves. So this is how it looks. We basically put the challenge design on Zenodo. When you click on a challenge, then you get a document like this, and basically in this case, for example, there's a remark that that's basically a revision of the challenge design document. And when you scroll through the document, then you see the changes highlighted in red. Yeah, so this was supposed to be constructive, but also according to the media reviews that we received, people still perceived it as very disturbing, saying that, researchers should be able to keep their freedom. Yeah, I have to say again, I'm mainly, or one of the main reasons I'm doing this job is that I like my freedom. So I really don't want to constrain freedom for no reason. But also I'm very concerned about scientific practice, and I really think we need to make a change. So because of all of this, we wanted to be even more constructive. Let's talk the last few minutes about the analysis of challenge data, which I think is actually also an underestimated issue. So what we found was that if people report on a challenge, quite a big portion just reports ranking tables. We've already seen some of the issues with such tables. Box plots are used quite a lot, qualitative analysis, but that's about it. So the analysis is really quite basic. And luckily we work with a statistical team, and we basically came up with some potential solutions to overcome this. So let me show you two examples of the benefits. So here, in this specific case, we have two challenges. In one case, there is actually a clear difference between the performance of the algorithms. So this is dot and box plots where the individual dots represent the metric values on the individual cases. In the second case, we actually simulated this challenge by drawing the metric values for each algorithm from the identical distribution. So there should not be any difference in reality. And these both lead to the same ranking table. This is obviously a problem. So what to do with this? This is one of the methods that we proposed. So many of you are probably familiar with bootstrapping. In this specific context, it means that we basically draw from our test cases that are used for the challenge. So we draw n samples with putting back. And then we have, in this case, 1,000 artificial challenges for which we also have results. For each of them, we can compute a ranking. And then we can do something like a frequency plot. And here, in this example, you see that no matter how much noise we basically put, algorithm 1 always stays the winner, and so on. Oh, sorry. So I think this ranking, no, yeah, I think the legends are mixed up. So just that's the actual ranking that we envision. So this should be a 1, 2, 3, 4, 5. In the second challenge, we see something very different. So we see that depending on the specific data that we used, actually all the algorithms sometimes end up first or last. So this is one way of visualizing uncertainty in the rankings. Second example here, these box plots probably look pretty similar. And I think one problem with these box plots is that they don't show the relation between the samples. So in other words, you don't know which test case corresponds to which case in the other plots. So we came up with a method that actually handles this. I'm looking at the time, so I think I'm not going to explain this method in detail, but feel free, of course, to look at our archive paper. But what you see here is basically, you see these interconnected lines, which basically mean that there are several test cases in which all the methods perform poorly. And we think that this is actually an important message to know that there's cases that on which basically many or all the algorithms perform poorly, which is not the case in the first example. Yeah, so I will skip that explanation of how it works. If you're interested, we're always looking for feedback. That this is really just the first version of the toolkit, but we now have some more manpower to enhance the methods. All you need to do is basically put your metric results per algorithm in the tool, and then you get something like a PDF report out. And of course, you don't need a challenge to do this. Also, if you just want to benchmark your algorithm to other algorithms, you can do it. And if you have problems with the tools, I mean, there's some known issues, especially when it comes down to the number of cases that you have, please contact us. We're happy to advance the toolkit basically according to the needs of the community. Yeah, lastly, some open issues that I think are, some of them are actually quite exciting. I particularly like this one. So I remember when we organized the challenge and basically the deep learning had finally really come also to Maier-Hein, then everybody basically in their reports of how they designed the method said almost the same thing. And in the end, we had a winner, and I had no idea why that winner was actually the winner. And I think if you work on deep learning, you would probably agree that it's often not the network architecture that is so important. But a lot of people that are not so familiar with deep learning, they think, you know, it's all about the architecture. So I really like this figure from KIDS 2019. KIDS was the Maier-Hein challenge with the most participants, more than 100. And what you see is basically now the algorithms are sorted by performance. So this would be the winning method. But if you look at the topological, the network design choices, then, for example, the winner was a 3D unit-like method, but also the method ranked 100 was based on a 3D unit. So really, there's a lot of things that influence the performance that you cannot easily describe by topology choices, for example. And I mean, if you work with deep learning, you know this, right? How do you augment the data? All the little tiny details matter. So I'm wondering, and I'm really stuck here, to be honest, how we can really learn from challenges. So initially, a few years ago, I thought we could maybe describe algorithms semantically with an ontology or something, and then find out what makes the impact. But I think given the speed of the developments, it's actually really almost impossible to develop such an ontology. Yeah, so basically I don't have a solution yet to this one, but I think it's very interesting. Secondly, well, I'm really impressed by the math community sometimes for many reasons, and one is how they collaborate. So in this project, for example, they just solve problems together. So the big shots, they can do the hard proofs, and you know the students can maybe do the easy lemma, and then they solve problems together. And what we do is actually the opposite, right? So we have a challenge, and then everybody tries the same thing first, 3D unit, whatever, some incremental improvements. I don't know, I think it's pretty much of a waste of energy, and it would be cool to work more collaboratively. Also, I mean, I'm not a clinician, but segmentation does not really seem to be the most pressing clinical issue, but most challenges are based on segmentation. I think the reason is that a lot of challenges, almost all of them, are organized bottom up, right? So some researcher has data, and then they organize a challenge, and because there's data, even more people work on this problem, and so on. So I think top-down challenges would actually be helpful as well. And last point, very close to my heart, and I know that Ben is also concerned about this, is really, you know, we have all these breakthrough success stories in the media and in the papers, but really, if you look into the clinics, you don't see AI widespread. And from my point of view, one huge problem is the way that we validate, because I think what happens in most of the cases is that people take their data and then they split it in training and test, and then they have what is always so desired, same distribution of training and test data. And I don't think this is the way to go, because this is not what happens in reality. So as I think, as Ben put it, this should be part of the development process, and I agree. But really, I think we should go beyond this when we validate algorithms. Also frequently fighting with George Cardozo about this. Yeah, so yeah, this is I put it this here because I found a few supporting papers of problems with validation. So if you want to have a look, I put the links in that tweet. And this really concludes my talk. Yeah, I talked about a few different aspects related to challenges. I think we're far from done. There's a lot to do. And I think the community really needs a cultural change almost, I would say. And I really want to point out again that there's some true heroes. So if you think of only the reporting part that I talked about, we analyzed 500 competitions with 50 parameters each, 2 observers per task. This is 50,000 annotations alone. And these 3, Matthias, Lena, and Annika, really did most of the work. So I think that was pretty amazing. It took a few years. So thanks, guys, for letting me present this work. And I don't have time for this. Yeah, thanks also to the rest of the team. This was our last retreat, physical retreat. I miss it. Virtual cannot make up for it. Maybe we should do something like this with avatars. And yeah, I thank you for your attention.
Thank you very much. I'm clapping for the rest of the people in the call. This is wonderful. I think there's so much food for thought. And I think I can just reiterate what I said earlier. I think now I'm even more impressed about the community service you're doing with this type of research, because I mean, this is really about making the community better and making the research that the community does as a whole better. So I'm sure there are questions. Let me see if anything is in the chat. Mostly compliments so far. So let's see. If anyone has a question there, so there's something coming up. Jeremy, before I read this out, do you want to ask a question directly? If you can unmute yourself. Is that all right? Or let me. Maybe yeah, it doesn't have it. Okay, so yeah, go ahead.
Oh, sorry. Thanks so much for the really great talk, and also for organizing the mood challenge. You mentioned the complexity of defining labels and such. I was wondering if you could comment on the difficulty of defining labels in an outlier challenge, and also I guess inherently in an outlier challenge, you don't have an agreed set of targets or definitions for outliers. And as an extreme, someone could claim that any sample not in the training data is technically an outlier. And
Yeah.
how do you think that, or do you think the ranking could become complicated because of that?
I certainly think the ranking could become complicated. So it's a first attempt. I mean, I'm not the primary organizer. I'm just you know, more on the side. But we had some discussions of it. So for those of you who are not aware, so there's a team that's this year organizing a challenge on outlier detection, and it's really hard to come up with a good strategy because also because of the cheating issue. So if you go for only outliers that people are aware of, then they can easily, you know, adapt their method to it. So on the other hand, if you use outliers that are artificial, then you could claim that that's not realistic. And I think the discussions that we had were a little bit similar to the ones that we had in the context of the medical segmentation decathlon. So most of you may know that was a challenge in which you had to solve 10 segmentation tasks basically with one algorithm. And we had very, very controversial discussions to the point that members left the team about the metrics to be used. Because so one part of the team said, basically, we have to address a clinical problem and the metrics need to represent the clinical problem, similar to what I said before. The other part said, well, but we're looking for a method. So we define the challenge as finding contours, irrespective of what the clinical challenge is. So that's two very different viewpoints. And I think we ran into a similar problem with the OOD challenge. Maybe it's too early to comment too much on it, but I'm happy to maybe resume discussions when the challenge has actually been executed.
Great, thanks. I think Bernard had a great follow-up question on the issue of collaboratively solving some of those challenges. Bernard, do you want to ask directly?
Yeah, sorry, I have to put on pants first. Yeah, Lena, thank you very much for this great talk. I strongly agree with you because what you said, I think 3-4 slides before the end, that you're impressed by the maths community is quite true. But I'm wondering, what do they do differently? And if we can actually decide on our working mode, or if this is decided by quite a number of third parties.
Yeah, I mean, I put that as a discussion point because I don't have an answer yet. But in the end, I think we have two challenges. So one is, I guess, to design the problem in such a way that it can actually be, you know, solved in different ways. So I think this may be a little bit more straightforward in the math community, where, you know, the big people, they already know which small lemma they have to solve, so they know it can be done. It's just basically a work to do it, so they can outsource that. So it's I think that part is maybe easier for them. I don't see such a straightforward solution in our cases. Maybe you do, then I'm happy to learn about it. The other part, I think, is about incentives, and basically, why do people participate in a competition? Often they want to be maybe the best. That is very contradictory to collaboration. So I think we need to find incentives for participating. And I think that actually is a solvable problem, because now, for example, with journals like Nature Scientific Data, you see that all of a sudden people start sharing their data more because they have an incentive. They get a relatively high impact journal paper for it, they get citations for it, so they start sharing their data, although maybe a few years back they would argue, well, but I need it because I need to develop my methods first or whatever. So I think the incentives part is probably solvable, but not yet solved.
Yeah, I agree. Thank you.
Wait, let me check if there are more questions. I have one on the issue that you mentioned about the metrics of challenges often not well aligned with maybe the clinical need. Do you think there's a general problem that we don't have enough clinical people being involved in setting up these challenges?
Yeah.
What about making it a requirement to have a clinical advisor for each challenge? Or maybe that's already a thing.
Yeah, that's a good idea. I haven't thought about it. That would be a nice parameter to add, clinical advisor. Yeah, no, I agree, because we just do have complementary knowledge as well. I mean, I have recently been involved from challenges organized more from the clinical side, and they have the opposite problem. So they come up with solutions where I say, okay, this doesn't work technically, right? So they, I don't know, they mix training and test data, or they use test data that's already out there, or more problems on the technical side. So yes, I agree. That's a good point. Maybe we actually put this on the list in the system. And what is good is, so I'm actually in contact with people from ACR and RSNA as the representative for MICA challenges, and they really want to push this topic and also the collaboration. So they say the same. They have a lot of challenge participants actually, but they want to have that link to our technical community. So if anybody has ideas how to move forward, any creative ideas, I'm happy to pass that on to them.
Great. If you have time for one more question, which just came in. So Miguel is asking about the issue of people, or some people maybe having more compute resources than others. So there might be large groups or even groups based in industry who could run massive like ensemble models, which we know often performs better than what maybe people can do in smaller labs and so on. Is that something that we should consider as part of the challenges as well, compute resources?
Yeah, I agree. So I actually brought that point up to NVIDIA. So the same line of argumentation. So I asked whether maybe it could be an option to at least midterm provide resources, compute resources, to compete in a challenge such that there's not such a bias against the richer teams. I think that's it's a really important point as well. Yeah.
I hope that answered your question, Mika. I took the liberty to ask it. Thank you so much. We're over time. We don't want to take much more of your time. Thanks for joining us. Thanks for giving this very, very insightful talk. And I think there's lots of follow-up thoughts going on in people's minds. And I'm sure this discussion will come again and again. Thanks so much, Lena.
Thanks for having me.